So now that we've talked about the Handy microservice structure, functionality, and implementation, let's turn our attention to the Zippy microservice. So the Zippy microservice is in some ways a bit more conventional than the Handy one was. It uses the Jakarta Persistence API instead of using the R2DBC reactive relational database connector. And it, however, does also use Project Reactor reactive types in a somewhat clever way, perhaps a little too cute way, to provide an interface that still appears to the client as if it's reactive, even though the implementation really is not reactive. So let's go ahead and take a look at how this works. Some of this is pretty much review of what we've talked about before, because we've already shown how this works with Handy. The Zippy application is very, very similar. It's an application which extends the base application, and it's got some annotations. Two of the three annotations are identical to what we did before for the Handy application. We were making it a Spring Boot microservice. We've got an entity scan that goes and looks at the quote entity class to get the fields for the columns in the database. But we do have one difference here, which we're going to enable the JPA repository. So before we had enabled the R2DBC repository, now we're enabling the JPA repository instead. And that, of course, uses a different implementation class. Also, like before, once we're done with this, we have a main method that's the entry point into this microservice, and it goes ahead and calls up to the base application run method, passing in the Zippy application class. All right, nothing too profound there, quite honestly. Let's take a look at the Zippy controller. Likewise, nothing too profound here either. This is very much like, paint by numbers or cut and paste from the Handy controller. In fact, it's pretty much identical. It's a REST controller. It's got a couple of auto-wired fields, one for the context, one for the Zippy microservice implementation, the Zippy service implementation. That looks the same as before. We've got this mapping for the info that Eureka can use in order to be able to find out if the Zippy controller is up and running. That works exactly like we saw before. We've got some implementation methods here that they're really not implementation methods, they're really the endpoint handler methods. And these methods handle get and post requests that are sent to it from the client or clients. So we've got get all quotes, post quotes, search. There's also a search EX method that I don't show here, but it's the same basic idea as search. And then you can see that these methods all return Flux objects based on the responses we get back from the service. And we also use, as before, the get and post mapping annotations to instruct Spring what kind of requests these different endpoint handlers are expecting to receive. And you can also see that in the case of the post mappings, we're using request body annotations so that we can have Spring fish out the list of integers or the list of queries from the request body, the post request body. So we're now going to turn our attention to the Zippy service. Unlike the Handy service, which is really just a total pass-through to the underlying Handy repository, which was this reactive quote repository, the Zippy service actually does a few other things, although not a whole lot more things. So it's a service, of course, which means it implements business logic and enables auto detection and wiring of dependent classes via class path scanning. It's got an auto-wired repository, which is the JPA quote repository in this case, not the reactive quote repository that we'd used in the previous Handy microservice example. And it's got a bunch of methods. So we can see we've got post quotes, search, and search EX, and there's a few other ones too. And notice that these methods are not annotated with anything. They're just good old Java code, and they take what's passed to them by the controller. All methods return the Flux reactive type, so we can kind of stream the results back to the client and keep things a bit more asynchronous. And the other thing these do is some of these methods forward to the, well, actually all the methods forward to the JPA quote repository. So they all forward in one way or another. However, this method actually does a bit more processing. So this method, as we see when we look at the implementation slide, implementation example, this actually does some parallel processing using some Project Reactor mechanisms to enable that. Each object is encapsulated by a list. The things that you get back from the JPA repository are list return types. And so we're going to convert those list return types into fluxes by using the from iterable factory method or some variant of that. The last piece of the puzzle here is the structure and functionality of the multi-query repository. This is actually somewhat similar to what we saw before, except now we're going to be using the JPA. So we have the multi-query repository interface, just like we did in the previous example, which allows us to do multiple queries at once, especially queries that are not going to be something that's defined by the underlying Spring Data API keywords. And then we're going to have this method, which is called find all by quote containing ignore case all in. And this method cannot be generated automatically by the Spring Data API. So instead, we're going to have an implementation that uses the repository implementation pattern. And this implementation is going to use an entity manager, which is provided for the JPA to give you a database session, providing the main API to perform CRUD operations, synchronous CRUD operations, and querying of the database synchronously. And then we have this method implementation, which is, again, quite a mouthful. But basically what it's going to do is it's going to use the programming means provided by JPA's criteria builder and criteria query and ID expression and so on and so forth in order to be able to find all the quote objects to contain all the queries, ignoring the case. And we'll see how that works when we look at the next part of this lesson. So that's the end of the walkthrough of the structure and functionality of the Zippy microservice, which is similar but not identical to the Handy microservice.